All right, I think this is the best way for me to do this. You're not really going to be able to see me, but you can see the problem a whole lot better. A couple of AP problems that you looked over here, and hopefully we'll deal with any issues that you might have with it. You've got a particle moving along the plane. You've got the dx dt and dy dt given to you. You've also got an initial position. They tell you when t equals 0, the x coordinate of the position is 0, the y coordinate of the position is -4. Right? So that's like the location that's on your coordinate plane. Part A wants you to find the speed. First of all, remember from the last video, speed, it's the square root of dx dt squared plus dy dt squared. And so your dx dt is given to you. You plug in 3, you get, that's 13. dy dt, you plug in, it's whatever the sign of 9 is. The calculator does that for you. And it's just the square root of dx dt squared plus dy dt squared. That number should come out of your calculator. And then for the acceleration vector, we haven't talked about that yet, but if we take the second derivative here of x, so basically the derivative of dx dt, which should just be 4, and then the derivative of dy dt, so that's going to be cosine of t squared times 2t if you did it by hand. Remember, you can also just do math 8 there. You're taking the derivative of dy dt and plugging in your 3 to get that value. Make sure you're in radians. That's not asking you to find the second derivative, like where you do like the change in dy dx over dx dt, anything like that. Just simply saying, take the derivative of dx dt, take the derivative of dy dt separately. Slope of the tangent line in part B. We get dy dx by doing dy dt over dx dt. And so if you plug in, it's basically sine of 9 over 13, I guess, just to get the answer there in part B. Part C wants the position of the particle at time t equals 3. Remember, if you want to know your position, we care about where did we start, and then what's our displacement? How far away are we from that starting point? So that's why you see there looking for the x coordinate of the position, 0 plus. That 0 is there because that's the initial position of in the x direction of the particle. And then if you integrate dx dt, again, you could do that by hand if you wanted, but just do math 9 from 0 to 3. That gives you 21. All right, so the displacement's 21, the starting position was 0, so your ending position in the x direction is at 21 as well. Now if you want the y coordinate when t equals 3, same process, that -4 is your initial position for y, and then you integrate dy dt from 0 to 3. That's not something you could do by hand. You'd have to do that in your calculator with math 9. Now if you integrate from 0 to 3 there, I guess you get, it's like 0.774 it looks like. That's your displacement. That tells you you're 0.774 away from your starting position. But your starting position was at -4 already, so you've got to remember to add that -4 in. That's very much like back when we were doing rate problems. It's very much like there were 1,000 gallons of water in the tank at the beginning. There was this much sand on the beach at the beginning. And then the integral tells us the total change in that thing. So you just do it separately for x's and y's there because you've got parametric equations in terms of both x and y. So your position has both an x coordinate and a y coordinate there. And then finally, total distance traveled. And we learned that formula last time. The integral of that expression that is the speed. You'll notice that that speed expression is the same as you had in part A. dx dt squared plus dy dt squared, take the square root of the whole thing. And that's the same thing that you had up here. They just happen to plug in 3 in that one. Integrate that from 0 to 3. That's going to give you your total distance traveled. That will also give you the arc length of that particle traveling between 0 and 3 seconds. I guess it probably is here. Our arc length and total distance traveled are the same things. And you may or may not know what arc length is yet, depending on if we've gotten there in class. So that's a look at the first problem. And we'll take a look at problem number 2 here, my high-tech system to switch us to problem 2. see if that's still in on the screen. You can still see it okay. It's a little bit. There we go. Another problem where we've got the particle moving along. The velocity vector is given to us there, right? Cosine of t squared and then e to the 0.5 t. And they give you an initial location of that particle at 3, 5. So part A asks you to find the x-coordinate of the position, very much like part C of the last problem. Except here we just need the x-coordinate. So we know the initial x-coordinate is at 3, that's given to us. And then if we want our new position there, we need displacement. So just take the x component of that velocity vector, just that cosine of t squared, integrate that, that'll give you displacement. Then factor in the plus 3, and you end up with 2.557. That's when it says uses initial condition there in the scoring guide, that's what they're talking about. Did you keep in mind that, hey, this particle started at 3, and so when I do that integral, it just tells me how far away I am from the starting point. Part B says there is a point on the curve where the tangent line has a slope of 2. So we have to find the derivative, dy dx, by doing dy dt over dx dt. And then those are both given to us. Those are in your velocity vector there. Since the velocity is already the derivative of position, right, you're just taking what's given to you, dy dt over dx dt, set that equal to 2 in your calculator, and solve for t. Right? So you get 1 point there for showing them that you understand how to find the slope by doing dy dt over dx dt. And the second point for actually finding that value in your calculator by graphing and finding an intersection or something like that. Part C wants the time when the speed of the particle is 3. We know we get speed by doing square root of dx dt squared plus dy dt squared. Now they were a little bit obnoxious here. I'll see if maybe I can squeeze in here and show you why they did this algebraically. Clearly here's dx dt as cosine of t squared, so cosine squared of t squared, that's dx dt squared. This is coming from the fact that you've got dy dt, which is that squared. You're raising a power to a power, so you're multiplying those exponents, so it's e to the 1t. And that's where that e to the t is coming from. If you left it like that, it's totally fine. You'll get that point for writing the speed in terms of t. And then wants to know when is the speed equal to 3. So set that expression equal to 3. Again, make your calculator do the solving for you. And then finally, find the total distance traveled again. Same as arc length, if you know what arc length is. Integrating from 0 to 1, they give you the bounds of that speed expression. So hopefully you had the right speed expression in part C. Does not have to be simplified all the way. This is one of those cases where if you had the wrong expression in part C for speed, but then knew to use it in part D to find total distance, you might get one of those points for being consistent but wrong. So that's your total distance. Again, calculator will give you that final number of 1.595. So hopefully those two problems made sense to you. I gave you the average scores there, just so you kind of get a feel for what you'd be expecting to get. It's about 5 points for the average of each one of those. If you've got any questions on those, we'll try to find some time to do that in class, either maybe as a warm-up the next day I see you or during score, just kind of depending on what day it is. So go out and enjoy your day. Be careful.